Welcome to today's Explainer. We're diving straight into a piece of tech that, well, you've probably seen it hijacking your social media feeds lately. We're looking at a breakdown from Tech Reader magazine all about Unitree's AS2W quadruped robot. Now, this wasn't just another run-of-the-mill tech demo showing off shiny new hardware. No, this specific robot triggered a really rare, totally visceral moment of collective online confusion. I mean, people were literally hitting replay, just staring at their screens, trying to process exactly what on earth they were looking at. It exposed this fascinating reality. We are just absolutely not prepared for machines that move like living, breathing creatures.
And that perfectly captures the growing tension here. Viewers honestly weren't sure if they were watching a programmed machine or something way closer to an actual creature. I mean, as this thing sprinted over rough, unpredictable terrain, it wasn't just that it was moving, it was how it was moving. It leaned into its turns, kind of the same way a dog might when changing direction at full speed. And when it slipped, it didn't just mechanically recalibrate like you'd expect. It snapped back with this movement that felt uncannily, almost eerily biological. The line between silicone and biology suddenly looked incredibly blurry. It genuinely caught people off guard.
So this brings us to the core question of this whole explainer. What happens when a machine just stops moving, like one? You and I were totally accustomed to machines looking and acting rigid, predictable, and distinctly artificial. But when you strip away that predictability, the psychological reaction shifts dramatically. This profound uncertainty, this total disruption of our expectations, is exactly what caused that footage to spread like wildfire across the internet. To really wrap our heads around this intense reaction, we've got to look at the physical mechanics. Historically, right, a machine has always looked and moved like a machine, doing its choreographed tasks, totally rigid. You'd never, ever mistake it for a living creature.
But what's really interesting about this comparison is how you can actually see the evolution of the tech. Think about earlier robots. They had this stiff gait, very deliberate balance, and their autonomy felt kind of hidden behind these careful, highly choreographed demonstrations. Well, Unitree's AS2W basically takes that whole pattern and throws it out the window. Its joints flex with this tendon-like elasticity. It literally anticipates uneven ground and actively shifts its posture. And like we talked about, when it slips, it recovers with a reflexive snap. The autonomy here is beautifully, and yeah, maybe a little terrifyingly, visible in the physical motion itself.
So what is the actual tech behind this biological illusion? Let's clear one huge thing up right off the bat. There is absolutely no off-camera operator with a joystick here. The AS2W is operating entirely 100% on its own.
This biological fluidity that we're seeing, it's actually just a continuous loop of incredibly fast math. In literally fractions of a second, the robot continuously maps the ground beneath it, mathematically predicts exactly how its next step is going to land, and then adjusts its gait in real time to compensate. It's an absolute testament to how fast and honestly how sophisticated roboticists have made these predictive algorithms. Because this processing loop is just so tight and responsive, it essentially mimics biological reflexes. And when it starts moving like a creature, our brains instantly reassess it. But you know what really amplified that biological effect and caught people completely off guard? The sheer velocity, 6 meters per second. Now, to put that into perspective, that is incredibly fast for a piece of heavy machinery moving over rough terrain. It's this massive speed metric combined with that fluid, organic processing that truly shocked the public. I mean, it moves so fast and so smoothly that viewers almost instantly started imagining scenarios that go way, way beyond what the engineers actually designed this thing to do. Which, of course, directly led to the inevitable internet reaction. Because the robot moves with so much speed and, frankly, so much confidence, the comment sections on these viral videos just flooded with dystopian sci-fi comparisons. People were instantly referencing those terrifying robotic dogs from Black Mirror or the autonomous weapons from the Metal Gear games. It tapped right into that collective cultural anxiety we all kind of share about science fiction becoming reality, specifically those stories where machines move with a bit too much intent and a bit too much confidence, you know? But if we pivot away from the internet's wild imagination for a second, it reveals a completely different picture of grounded, practical intent. Unitree isn't out here trying to build dystopian sci-fi villains. They are actually trying to solve highly complex, real-world physical problems. The company has actually spent years targeting environments that are just too dangerous, unstable, or remote for human beings. We're talking about crucial stuff,
search and rescue missions in collapsing terrain, carrying heavy scientific equipment into the field, or even just basic cargo transport. In fact, earlier models of this tech have already been tested out in disaster response pilot programs over in China. So the AS2W really isn't a weapon at all. It's an advanced tool specifically designed to navigate a highly unpredictable world with unmatched speed and stability.
Yet, even with all those practical, life-saving uses, this viral moment created a really fascinating divide in how we interpret technology. On one side, you had engineers and roboticists looking at the video and praising the unbelievable balance, marveling at just how quickly those predictive gait algorithms have matured. But casual viewers? They were experiencing a powerful mix of total awe and deep, undeniable discomfort. This footage didn't just spark a debate about the technical details of robotics. No, it sparked a much deeper debate about physical presence. And the weight of this technological shift is massive. The AS2W sprinting across a hillside wasn't just some cool tech demo. It's an undeniable preview of our autonomous future. We are literally entering an era where machines won't just be confined to factory floors or screens on our desks. They are going to be moving through the real world with a commanding physicality that forces us to confront our deepest biological instincts. Which leaves us with one final provocative thought to chew on. What does it actually mean when a machine occupies physical space with the exact same fluidity, reflexes, and confidence as a living creature? The hardware is here, the predictive math works, and the autonomy is visible. But society is clearly still trying to figure out how to feel when silicon and steel start acting like they're alive. Thanks so much for joining me to unpack this explainer, and I'll catch you next time.